Yes, hello everybody. Thanks for coming. It looks like I'm between you and the party. A party that might last a little bit less than expected, if you've heard the news. Anyway, I'm happy to be here, happy to present in person. We've all been through the years or year and a half of online conferences. It's definitely much better and much more energy that we get here. So I'm Vanhoutte from Belgium, Azure MVP and CTO at the company Coded. So we are based in Belgium and 7 other Western European countries. And we focus on cloud solutions with Microsoft Azure, typically IoT integration, data analytics. So let's say the backend stuff, less on infrastructure, more on platform as a service. Enough about us. This is about the session, and maybe by a raise of hand also to understand where your experiences are or not. I'd like to understand who has been working with Microsoft Azure in general already. Okay, who has been doing things with time series insights? Okay, 30%. Azure Data Explorer? Few. Azure Machine Learning or Data Science in general, and Azure Stream Analytics. Okay, so these are also the topics that I will cover. You will not see all the details because I could happily give this session in 2 times 1 hour, but I will pack everything into 1 hour so that you get an overview of what is possible, and I will focus on time series data. So I'll explain what time series is, what type of data that is, and then what you can use in the Microsoft Azure service platform. Think about time series insights and Data Explorer. We will also look how to predict the future in a predictive maintenance scenario, and we will use Azure Machine Learning for that without details, so you don't have to worry about neural networks and so on. If you want, the code is shared, but I will not dive in those details, so no worries. And I will show how to use those models in Azure Stream Analytics. So that's what we will do. But first, to start, a little bit context on what makes time series data specific and what is it different from other things. There's different types of, let's say, messages or exchanges that happen between systems in IoT scenarios and so on. The first, let's say, set of data, you could say is intent. It's giving a command, please open this door, doing a query, how much people are in this room, doing an assignment, doing an update. So you have an intent and you expect something to happen. Another thing is more like a fact. It's 25 degrees here. Report of this. You know, a user has logged on the website. These are just facts. And you can say that the left side is typically messages and the right side is events. And we will focus on the events today. But you also have different types of events. You have the discrete events. These are typically independent, like the door is open, the light is on, the user has logged on. These are typically things that are just standalone. They typically indicate a stage change, and you can act on that. A common service in the Microsoft Azure platform for that would be Event Grid. The ones for the commands and so on, that would typically be Service Bus. And here we focus on time series. And what is time series? It's time ordered. That is the biggest issue, or the biggest aspect of it. You really need to have the dates, the events in the right order, because you want to look at trends, you want to see at things. So the sequence is important. And context partitioned is also a concept that is important. What I mean with that is if in IoT, for example, you have multiple cameras that detect events, you will look at the time per camera typically. So that would be partitioning by camera or by devices. And that's an important thing as well. And you analyze on top of these time series. Okay? Examples, easy enough to understand: stock prices, weather, and temperature readings, the number of passengers on the airport, and so on and so on. And there's 4 important components that make time series specific to work with. 4 components that you can also use to look at the future if it's possible. The first one is the long-term variation. So that is the trend. That's really ignoring all the variations that you have, and you focus on the longer-term trend. That's a very common thing. For example, here we see the flights that you can see per season over a few years. I think 100 years, number of flights that are taken. And you can see that there is seasonality, and that's the next one. But the long-term trend is up. That's an important one. A cyclical effect is typically things that have an impact on economy, on political circumstances. So these are less short-term specifics. And this is probably one that you will definitely recognize, the seasonality, things that come back. Every day between 8 and 5, we see this on the website because people are more active. Every Black Friday, for example, every Christmas thing in the retail, it's a very common thing. So that's seasonality, things that come back over a shorter period in time. And the last thing is what we call the residual effect. That's typically things that are not necessarily easy to explain, but if you would make the sum of all these previous ones, the remainings is the residuals. That's the ones that are just, fluctuating around very small things. All right? Now, the scenario that we will use is a scenario that is also based on open source data sets from, I think, NASA. And it's about engine telemetry. So this is, if you want to read more about it, the link is there. So it's a predictive maintenance data set. I think 100 different engines have every X minutes or seconds, I don't know the details anymore, a reading of, I believe, 27 parameters. And they will use that to see when prediction or when maintenance has to happen. So that is part of that data set. And it's based on gas turbines. Okay, so it has 100 engines, and we will use that to train models and also to send data into IoT Hub. And that's something that I'm also happy to share here is you can just install this if you want. So if you want to play with IoT Hub, if you want to play with time series data, this is just an open source Docker image that you can run. You can run it in IoT Edge if you want to play with Edge. You can just run it in an ACI in the cloud or on your local laptop. The only thing you have to give is a connection string to your IoT Hub. If you spin it up, it will automatically start sending for these 100 engines. So 100 devices will be created on your IoT Hub, and they will be sending every, I don't know by heart, X seconds, a cycle of data. And you can start using that. So that's very easy. You don't have to bother about finding data. You can play with this as well. I also have on another project a similar simulator that fakes cars that get scanned by a camera on the road. So you have license plates, you have the make, you have how fast they are driving and so on. And you can also use that. So just on GitHub, easy to find. Now, very high level, not diving in these details, but this is what we see typically as the reference architecture for our IoT solutions. Also on the left side, left of the red line, that's what we call edge. So that's everything that you have in the factories or in the buildings or in cars and fleet. So you could typically have N setups of that. And then everything right side is what we will focus on today, and that's in the cloud. So you have the whole hot path, cold path, and long-term storage that you build in the cloud. And then, of course, you integrate with applications and so on. Now, these are the services that you typically link to those concepts. And the services that we focus on today, I already mentioned them. They typically are in the hot path analytics. And the colder path is what we see for a Data Explorer. So we will talk about time series insights, Azure Machine Learning, Stream Analytics, and Data Explorer. Logic Apps is not being used, but as a concept, we will mention it. Okay? So this looks very overwhelming potentially. The reality is that you typically take a shorter version of things. You don't need all the services, but we typically start with that reference architecture and throw away things in order to end up with a solution that works for the customer. So for this demo, this is the setup that we will build. So on the left side, you have that module that I mentioned, the simulator, that sends data into your IoT Hub. We will show how time series insights is being used without writing any letter of code. And you will get all of that richness of the time series exploration with Data Explorer, which is also called Custo in the code name at least. I will show some queries against that same data that gets in. And we have Stream Analytics that will then detect if maintenance is needed for one of these engines. And it will use the machine learning model that we train and that is hosted on Azure Machine Learning. So if it gets something there, it will then call a function that publishes the event. But I will come back on that. And we have on the right side the logic apps. Okay, so I hope that gets at least a higher helicopter view so that we can dive in the details of the first service, which is time series insights. So what it is, IoT data typically has not a lot of context. If you see a typical IoT message, most of the devices, they don't know they belong in building 5. They don't know that they are of customer X. That's typically data that is not inside those messages. What is in the messages is the things that are just, the events. It's this amount of temperature, this is the humidity I sense, things like that. So what you typically do is you need to add context. You need to cross-reference with things and so on. And something that in the IoT landscape has been built is ADT, so Azure Digital Twins. So they have a link with time series insights as well, in order to add structure or hierarchy in your IoT data. So you can link a device and you can say this device belongs to, I don't know, this customer and so on. So you can build a hierarchy, and we will show that. So that's the whole contextualization that you also need. What is also important that IoT data, you might focus on the recent, let's say, hours, days, depending on your use case of data, but you typically don't want to throw away data. You also want to have longer-term vision and trends. So that's the infinite retention that you see on the bottom right. And those concepts and those needs is what is being used in time series insights. And how is it built? Actually, they have your data processing engine on the top. So what they do there is actually they have ingestion from IoT Hub and from Event Hub. So these are the two, let's say, streaming engines that you get with Microsoft Azure. And you have an out-of-the-box integration with that. So you can set up things like consumer groups that just start reading from one of these streaming engines, and they are getting the data. You can then have your time series model, which you can see here on the right. So the model is the hierarchy that you can define. You can say these devices, they belong of this type and so on, and I will show that. And then the data is being stored in warm storage, always directly into the warm storage, but it's up to you to specify a retention period. It could be 7 days, could be 30 days, it could be longer. Once the data is, let's say, longer than that retention period, it gets moved into cold storage. So cold storage can have the infinite retention and is actually using data lake behind the scenes in your storage account. And you can read that with common open source files like Parquet and so on for the more big data solutions like Databricks and so on. The good thing is that if you query your time series, you can just use a query API if you want to have custom applications that show graphs, or you can use the time series explorer. And the good thing is that you query the API, and it's up to the API to see if the data has to be fetched from warm or cold storage. So that's quite transparent, although you see it. And pricing is, of course, different. Warm storage will be more expensive, but you also get, of course, much better latency. All right? With the metadata, I will focus on that in the demo, but you have types. So a type is, for example, this projector, this engine. So that's typically a type of a device. And a type of device has, there you typically specify the fields that you have. For example, the light, the temperature, things like that. And then you can say, these devices, I will link them, and that's the instances. I have 100 engines, so I have 100 instances. And I will say, these instances have certain fields, and that makes them belong into the hierarchy. But you will see that in the thing. So that's metadata that you link on your server side when you're modeling stuff. And for that, let's switch to the first demo. So I hope that everyone is familiar with the Microsoft Azure portal. So what I can do is set up a new time series instance, but I will not do that because it takes a little bit of time. The only thing I will show is that, and I will try to zoom in. Oops. So you have, what is important is that you have the event sources. And here I have the event source, and I can easily add one if you would like that. And here it has a type Event Hub, but you can see I can add an IoT Hub. So the only thing you have to specify here is give it a name, then give your specific, for example, your IoT Hub. You select your IoT Hub instance, and that's about it. Zooming out. And here at the bottom, you also specify, as from when should time series insights start to read? As from now, so as soon as I start this thing, or you can give a specific time, or you can say from the beginning, because these IoT Hub and Event Hub streams, they actually keep position. So they keep track of where they were. So you can have, it's like a moving cursor server side. And then the timestamp property name is an important one where you can specify that if you have a timestamp in your event message, and honestly that is what is typically recommended, that if a machine is making a reading, that it adds the event time of that reading in the message, then you would link that in the same thing. That's all. If you do that, and you have data coming in from JSON and I believe CSV as well, then automatically time series insights will recognize the schema, and actually it's schemaless, so it will just see the different fields and it will add them and make them visible in the time series explorer. So that's the only thing you have to do. Create a new time series explorer, you link your IoT or Event Hub, and then you have this. So if I go to the overview, and I cancel what I did, I can say go to the time series explorer. And then I move to a different portal. And this is actually a portal that you can give access to your analysts, to people that you don't want to touch your Azure stuff. Just look at the data, but don't touch the Azure portal. That's what you can easily do here. And as you can see, this is at the top, apologies, an overview of the time that is available. So now we have the last day. And here on the left, I have a hierarchy that I specified. I just gave these names. For example, this is the BMAP type engine, and I have in Asia, I have 13 engines, and these are the names, for example. So that's what I say. That's adding the extra context and extra metadata to these fields. Now, what I can say is I want to explore certain things. For example, for this engine 4, let's take the fuel-air ratio, the bleed enthalpy, and the corrected fan speed. And I click OK. And what you can see is automatically that these fields get added here. Over a period, as you can see, from 1 day. If I say I want to have a shorter period, it zooms in. So you can perfectly zoom in. You can say, okay, for example, this is the one cycle that I'm now interested in. So I click this one and I say zoom. And again, the data gets zoomed to that certain level. Another interesting thing is that, for example, I could say this is an interesting peak. So I will now explore the events. And behind the scenes, it's actually just storing the incoming data that I had in JSON. So I can see all the actual fields, the raw data for every single event of engine 4 that was ingested in my storage. So you can see the inlet and the temperature for the outlet and so on. You see all that values just visualized here. All right? So that's quite easy to, without writing any letter of code, you can zoom in, you can do all these things. What you can also do is save some views. For example, I have, I think here, I have an interesting view where I actually wanted to make sure that here on the peak 1, and you can see that you can add a marker, something like that. So I added the marker here, and I try to align the peaks of those things. And what you probably cannot see that good, if I don't zoom in at least, is you can time shift. So I shifted certain lanes with 43 minutes, with 70 minutes, in order to align that peak and to see if these peaks take a similar length. For example, here, all of that has been aligned. And you can see here that it was with a shift. And you can see that this peak is taking, or this cycle is taking less long than the cycle of this device, and so on and so on. All right? So to do that, you can just click here on a specific lane, and you can say the x-axis here, you can shift with X amount of minutes or hours, and so on and so on. All right? In order now to show how you can model and set these these extra hierarchy options, this is done in the modeling here. So you have the modeling that you can start by specifying the types. And here I have the engine with all the different fields. So all these different fields that get in my JSON message from my simulator or here. And what I also did is, for example, you can have calculated fields. So let's zoom in this one. A calculated field allows you to have a custom expression with a limited set of functions like this. So here I take the difference between the HPC outlet and the LPC outlet, and I save that as a new field. All right? So that's actually the data model for a specific device. I could easily have multiple engines with different telemetry messages. I could just specify multiple types. Okay? Now to create that, you can of course add all these fields manually here by adding a variable and so on and so on. What you can also do is you can upload a JSON file. So if you would go to the GitHub repo that I had the link in, the JSON files are there. So you can just import them and you can start playing with that as well. And then you have the hierarchies. For example, if you remember, I had this tree. You can perfectly start defining them here. And here I link engine 1. I say it belongs to these two different fields, and that will give it a place into the hierarchy. So this was the hierarchy here on the left, with Europe and so on and so on. Making sense? What you can do is share views with people. So if you see something specific in your data, you can always say, I will now share this one. You give it a link. If you have added these markers and so on, the other person that has to have access to this portal will be able to see the same view as you have seen it. But the good thing is that to get this, you don't have to write any letter of code, and it's a good way to easily start exploring the type of data that you get. So even in just the initial setups with customers that we see in pilots and proof of concepts, where they want to get a feeling like, can we securely get the data into the cloud? With time series insights, just by adding it, you know, it's a matter of 20 minutes and then maybe an hour to add the hierarchy. But just by doing that, you give these customers at least already a feeling that this is the data that we see. You don't show a database table that is meaningless things. You can really, you know, show and give the customer the confidence that there is data easily flowing in. All right? Any questions? Don't hesitate to just shout or raise your hands on that.
The front end you're showing here, that's Azure, obviously. If I would like to have this in my own application, is there a way, for example, that I can create a view in here? Is there any tool that can automatically
yes.
use that view?
There's two options. One option is to use the query API, and believe me, it's horrible, but it works. Just it's not easy to, you know, to query, but once you have it, it works, right? It's just a strange structure, if you ask me. What you can also do is rehost this control in your application. There is samples online. I even started, I'm not a front-end person, so I started by trying to rehost it in a JavaScript application, but I didn't succeed yesterday. But there are samples online that are there. So maybe I should add it into the in the links at the end of the presentation. But you can either rehost it or just query your thing and then build your own graphs. Okay? Now, at certain customers, we started with TSI, but it became clear that we needed to have more. We had to get more information out of the data. We needed to have more query capabilities. And that led us sometimes to ditch TSI and to move to Kusto, so Azure Data Explorer. Actually, behind the scenes of TSI, there is Azure Data Explorer. So TSI is being built on Kusto. So the thing is, if you move to this, you get much more capabilities, but also much more complexity for you. So you have a cluster to set up, and you have to write queries that are in the language that is called Queql, KQL. So the Kusto query language. So the principle to do it, and that's also quite easy, is create your database in your cluster, and you can specify scaling, of course. And then you have to ingest your data. And again here, without writing any letter of code, you just add a data source, in my case, my Event Hub, and the data gets streamed automatically into your database. The table is automatically generated based on the schema that it detects in your incoming data, and you can start querying. And then you can use the Kusto Explorer, which is typically a portal that you can use to start playing with. Obviously, if you want to build your own graphs, your own scripts, your own queries, then you will use the SDK to use your data access. All right. There is integration with Power BI if you want that. So that's definitely possible as well. And there are some, if you're familiar with data science, like you have the Jupyter notebooks, there's also notebooks that support Queql. So where you have multiple queries that you can see, and they can render not just tables, but also graphs, but you will see that. With ADX, you have some specific time series functions. So you can do filtering of noise and so on. You can have some basic regression analysis. You have the decomposition of your time series with seasonality and things like that. And the functions are quite extensive and not that easy to understand. So I also want to make a claim. I'm not the Kusto expert at this time, to be clear. But these are the time series that you have. So the make series actually translates data into a time series object or series. And then you can start either decomposing it, you can get the seasonality, you can detect your periods, and the nice thing at last, you can also start forecasting. Although I've seen that the forecasting is quite straightforward and simple. So not taking all the seasonality, at least on my test data, into account. This is just if my queries would not work. So I will just assume that they work, but they are in the slides for later reference. So let's go back to the portal here. And this is my Kusto, so my Azure Data Explorer, and then I have a database here. I gave the database the name Engine Data, and this is what is important. If you have in your database, you have a data connection. And I will zoom in. Because here you have the health section that actually shows. So the only thing I had to do was link this, in my case here, with Event Hub. And then the data gets automatically streamed into this database. And this is, for example, the last 6 hours. So I started around noon with this ingestion thing. And you can see that the data gets ingested easily. Again, without writing any letter of code. The code is what you will do. The code is what you will do typically in writing your queries here. But I also have it open in another window. So for example, this is just quite straightforward, the type of queries that you can write. So it's not your T-SQL syntax. It is totally different. If you've been playing with log analytics and so on, this might look a little bit familiar. But you start with your table name, and then you have the pipe sign for every new thing. So you typically continue to build on what was the previous line. So here I summarize, for example, by taking the average of the core speed field, and I summarize by engine. So you could say that's a group by taking the average of that thing, if you make the link with SQL. I also say just take the 25 top, and you order them by the core speed. So the fastest 25 will be taken, and just render a bar chart in this case. Okay? And that's what you then see at the bottom here. The top 25 engines based on speed shown in a graph, in a bar chart. That's what you typically can do. And these are some functions that you can run to decompose your time series. So if I zoom in on the details here, this is, for example, a function that says the minimum time is 240 minutes ago, so that's 4 hours ago, and the maximum time is 10 minutes ago. So we will take that as the window of the time series. And this is what I said here. You make the series. So here I say, I now make from that table a time series object that is actually the average of the corrected speed, and you will take the minimum and the maximum, and you take the average over a window of 10 minutes in this case, okay? And you group them by engine ID. You see, it's not that straightforward if you're coming from SQL. It definitely has a learning path. And then I say, now detect the periods based on some parameters that I don't know by heart, expand it, and so on, and extend it now so that you have the things. And I here take the top two. Oops. And this is what you get. So this is the plotting of a specific time series object that you get with the reads linked. And this is then the forecasting of the next, and this is no longer the 6 hours, but I think we're forecasting 20 minutes. So I should change the title of the chart. But it's quite similar. I'm making the same series. And here I say series decompose forecast. So forecast 20 next fields with some specific parameters, like how do you do it. But you can see it's typically a regression that it applies, at least on my type of data here. And you can see that the red line is the trend that gets detected based on the last, I think, the same thing, 2 hours, based on the last 2 hours of data, using that specific field. So just for your reference, these queries are there. You get an understanding of how these things typically work and how the syntax is created. So if you now want to take this or these types of data and you want to use it in your applications, just use the SDK, use those queries, and you can start playing with it. What is important at the same time, that this is really powerful if you have like terabytes of data and so on. So this is really, really powerful to get summaries and things like that on huge sets of data. But it comes with a cost. I know from a customer that I was not involved in at our company, but that some of our architects worked with, that the cost of Custo was probably one of the highest of all the components in the IoT solution they had. But it was also one of the most important things to get out of it, because they wanted to have real, let's say, queries that had fast results over large amounts of data set. And if you want, you can see, some statistics on how much data was scanned. So something like the query plan, also in this studio. All right. Is it the column DB? It's a good question. So it's not a document DB that you might know. And I don't know the exact answer. So
it's not the old style.
It's definitely not a relational database. That's for yes. Okay, but good question to follow up on that one. Any other questions so far? All right. So what we did now was actually just visualizing data that we ingested. We did not touch the data. The data was just streamed, again, without writing any letter of code. The next thing that we typically would like to have is, if we get readings in our IoT backend, is to see, based on this previous readings from engine X, do I expect to have the need for maintenance? So that's a predictive maintenance scenario, right? And for that, you typically want to predict and learn from a data set that you have. And I will not, again, dive in the details of the machine learning here, but I will use and show how Azure Machine Learning as a service is being used in order to operationalize that model. What I also want to make sure that you understand is that you don't have to do machine learning, you don't have to do deep learning in order to predict time series. A lot of times forecasting can be done by quite basic statistical algorithms. Maybe the one that we have seen quite commonly in the news over the past 18 months might be the moving average. You know, the corona numbers, in the beginning they were very peaky, and then they averaged them out and you see like a slower trend. That's very common. If you look at stock prices, typically also they remove the day things and they look at 50 or 20 moving averages of the last 20 trading days, for example. So it's a very easy thing where you remove the peaks and you see a longer trend. You have other things like auto-regression with ARIMA and SARIMA. So SARIMA is then an addition for seasonality and so on. These things are quite often just available as packages in Python and probably also in C# and so on. So just give your data set and you say how far do you want to predict, and these things will do that for you. So not that complex. At the same time, if you want to go much deeper, you have other things. A nice one that is interesting is Prophet from Facebook or Meta. And it's an algorithm that really is good at the whole seasonality thing. So seasonality, again, from day to day, so your business hours, but also for your peaks in the sales and or retail, for example. So that's one that you can also easily use as packages. Definitely in Python. I haven't used it or tried it or looked it up for C#, for example. But I guess it's possible. And then the one that I did, that you can get the code from, is LSTM. And that is then the machine deep learning. It's a recurrent neural network that actually has, its LSTM means long short-term memory. So it keeps track and it learns what it should remember from the previous events that it got. And that's an important thing that we will not dive in the details, but that you understand, is that the time prediction that you typically do is based on the last X measurements. If I want to predict the time, you can say, okay, just very naive, I'll just take the last measurement and I take the same measurement for my next prediction, one further. And it will not be far off in a lot of cases. Of course, you typically want to predict a little bit further, and then the more you learn from the past, the better. But also don't learn everything, because before you start to apply things, you have to have that data set. Just for your reference, this is what we use as, let's say, a canvas to build machine learning. But this is the important concept. So DevOps, I really hope that everyone in the room knows those concepts and those methodologies. MLOps is the DevOps for machine learning. Not diving into details, but what is important, there's too many people, too many data scientists that are extremely good at building models, at building algorithms, applying them, but that might be too, let's say, absorbed with that sole aspect of AI. What I think is important is that we embrace those talents, but we integrate them in a full team approach. So that it has happened with me, it has happened with potentially other people that have been doing machine learning, is that you're building a neural network, for example, you get quite decent results, but you say, I will start or continue to tune, and your performance goes down, you don't have the same results anymore, and you forgot how you got to the good result, for example. Because it's all in your machine, you didn't check anything in, and let's say the good results were gone, and it's hard to get back, and you have to do all the things over and over again. So for that, what we see is that experimenting should happen. It can happen locally on your data, it can happen in the cloud. Locally on your machine, it typically goes much faster. You know, you get good feedback, but we typically take smaller data sets because you don't want to have, you know, your machine heating up constantly, but you focus on the syntax. You build your model, your network locally, but what we do, even if you run it locally, is that every experiment we do, we save it into Azure Machine Learning. So even if you have 5 experiments in 2 minutes that you execute locally, all the results will be in Azure Machine Learning. You will know exactly what parameters did you use for that script. You will know who executed it, and you will see the results back. You will see the exact script that was used at that point. And of course, the metrics they are tracked. So you can perfectly see how good, what the accuracy and so on of that model was. Even if you run locally. And if you then are happy with what you did locally, you can then say, I will now schedule my trainings in the cloud. They can run for hours on the huge data sets with different parameters. And again, they will be saved in the same registry of your trainings. That's what the whole experimenting is, where I think it's important. Without too much effort, you can have full richness of machine learning, and it doesn't cost anything if you execute locally. Okay? Now, if you are then happy with the results and you say, now I want to operationalize things, then you also do the CI/CD thing that we have seen with software. You have the same things. You schedule your trainings in the cloud. You schedule it against the data that you use at that point. And also you can think about versioning of your data. Because if data has been added into your live data set and you want to train on that data, it can have different results. Think back again about all these models that we have been training, let's say, pre-corona. A lot of them, if you would now retrain them on the, let's say, during corona time frame, a lot of the predictions will be totally different. Think about all the remote work versus buildings that were occupied in the past. So you register the model in your pipeline, it becomes available in your model registry, and then you can start using it. So that's what you can see all, without diving in again in the details of the machine learning. And what is important at the same time, if you start making predictions, that you try to link it with the actual results. It's not always possible, but for example, we had a project at the airport where we had to predict the queuing time at the security. Well, if we predict that, what are we now, at 4 or at 6, the waiting time in 4 hours from now will be 10 minutes, then it would be good that we save the prediction that we do now, and once the actual in 4 hours is there, that we can start seeing how accurate that prediction was. And that's what we call model telemetry. So you make sure that everything you predict, you link it with the actuals, and you can see how far you are with it. And there's error messages or error methods to see how far you are off. And if you have a certain threshold that you say, oh, we see that our predictions are not good enough anymore, you can reschedule your training. But you reschedule the training on the new data, and all of that can be automated if you even want. Although most people still want to have, let's say, an approval point before the new model gets approved, but still it's a possibility. All right? Just a shout out for an open source component, free for you to use, that we have been building is Arcus. It just hides a lot of the Azure Machine Learning SDKs on Python. So you can easily use that, and then you only have to use 3 lines or something and everything gets tracked. If you don't want, you can always have more code in your notebooks, but what we wanted to do is that the data scientists and the data engineers can just focus on their data models, and that Azure Machine Learning is just a matter of 3 lines and the rest is automatically done. So I explained how the training is done, experimenting locally, generating a script and then scheduling it in the cloud. And this is what I also wanted to share without the details, is that the impact or the size of your time window that you use to predict data against has a big impact on the accuracy. So the more data that you take into account in that LSTM network, the better. So you can see that a window length of 30 was, for example, the best approach. We had 93% of accuracy. Question? 30 was the last 30 measurements that we took into account to train the model as input for the model to get a quite accurate decision. If we had 50, but I think that slide is removed, we even had a better accuracy. But that means that you have to have 50 measurements in your production data available before you can start doing things. So that's a trade-off that you have to make. I will easily skip this for reference, but that's a long short-term memory how that works. Here you have it. So the larger the window length was to give to your machine learning model, the better the accuracy. All right? And you don't want to start overfitting. Now the thing I want to share is not how the machine learning works, but how I have set up Azure Machine Learning specifically. So if I go back to the Azure Portal. This is my third demo on Azure Machine Learning. So again, just like with Time Series Explorer, Azure Machine Learning has a separate portal that you can give to your data people without being scared that they will move your virtual machine somewhere. And this should be the Experiments tab here, where I just have the engine failure prediction, right? And if I click here, you can see these are all experiments that have been run. So a list of experiments. A list of experiments that I did, and some of them are scheduled here on my local machine. Most of them are scheduled in the cloud on CPU compute from Microsoft Azure. So typically here, I start locally. Once I see that it works, then I schedule it in the cloud. Of course, some things fail because you do trial and error. And you can perfectly see which ones has the best accuracies and so on. So for example, this one has a 95% accuracy. If I then click to that specific run, I can perfectly see, and again, without you having to understand what it means, but this is, for example, the arguments that I passed into my network to train. So for example, I said, you take a window length here of 50, right? You use that many nodes in the neural network for LSTM and so on. You have a dropout of 25, so don't bother too much, but I know exactly what has happened and why we got results at that moment, which was in October, and I got that perfectly. What I can also see is the metrics at that time. I don't know if you're familiar with the confusion matrix. I will not explain it too much because we have to look at the time. But this is the confusion matrix of that moment. You can see actually that we have predicted 84 that were incorrect and 170 that were incorrect. So the 170 we actually predicted there was no need for maintenance, while there was need for maintenance. So these were incorrect. And you can also see all of these things. And in the snapshot, I can perfectly see this was the exact same version of my script at that moment that the model was generated. So that's what I mean. You can have end-to-end tracing, and it even goes a little bit further, because this is my model registry. So here I have my machine learning model that I trained and that I also registered. So I make it available. And I can see it was linked with this run ID. So from the model registry that I have used, I can go back and I can see, oh, this model was generated by this person on that day with these parameters and that script. You see? And that's the end-to-end tracing that I think is extremely important, because if something happens, if we want to retrain things, we can exactly know what was put in production and so on. The other thing is, so registering a model makes it available for you to use, but you cannot call it, you cannot consume it. It's just registered, it's not hosted. Hosting happens in an endpoint, and I think this is probably the endpoint here. So you can see that we have a REST endpoint actually. So I have a score.py, and you can again get it on the GitHub thing, that actually exposes the model. So it loads it from the registry and it hosts it. So anyone that has the right keys, because it's secured as well here. And again, they are not hiding it, so don't memorize it. But that's the way you can now call my model from anywhere if you have the right keys and the right things. And this is hosted, in my case, on ACI, so on a container instance on Azure. You can also host it in functions or on your AKS, so Kubernetes cluster. That's all I wanted to show from machine learning, because now we will go to the stream analytics. Because remember from my slides that I said in stream analytics, we will now use that model that I just showed in that endpoint. Stream analytics, I think 30% have seen it or used it. You should look at it as standing queries. What we mean with that, you write a query, and instead of the query having a look at the data, you actually throw the data into the query, and the query keeps track of a certain amount of data, which is called a window, and it gives results, and it outputs constantly results. So that is Stream Analytics. Again, it's in the streaming, it's in the hot path, so you can link it with Event Hubs and IoT Hub. Always the same types of data for streaming, but you can also reference it with other things like blobs and like SQL databases, because again, you want to add metadata in some cases. So you have the inbound, which is reference or streaming, and if you have outbound things, you can save it into real-time Power BI dashboards. You can save it into blob storage, you can call functions, so you have a lot of output parameters available for you to use. In order to use that model that I did, you can define a function, a UDF, a user-defined function, that actually calls, in my case, the Azure Machine Learning endpoint. So there is out-of-the-box integration from here with Azure Machine Learning, and as you can see, the only thing I had to do was give the scoring URI, so the DNS that I have there in my endpoint of machine learning, and based on the Swagger, because that endpoint has a Swagger, automatically the function is created. Some syntaxes that you can take into account, just for reference again, but what you can do is you can define JavaScript functions, and you can then call them, for example, from the SQL syntax that you have in your query. But I think it will be much more clearer if we show the things in action. So in the dashboard, we have the streaming job. And here, the topology is actually what is key. Yes, so the inputs, the functions, the query, and the outputs, that's where the magic happens. I'm now showing the portal. If you're building the real stuff, I would recommend you to use the code plugin for ASA. It's quite good. You can test, you can even debug if you want. So I have an input. That same IoT Hub that I'm using in the other services is also used here. So the data is streaming from IoT Hub into 3 different places. I have my machine learning model called here. So with the machine learning function, and then I have the output. In my case, I'm outputting to table storage, but you have many other options. Now, the most important aspect is this one. It is the query. So here you specify the data that comes in, so all the fields I have specified. Then you start to do time windowing. So how much data do I keep in memory? So here I'm using a tumbling window of 24 hours. So I'm keeping 24 hours of last data in memory. And then I'm saying, I'm doing a select into blah, blah, blah. And here I'm calling needs maintenance. So needs maintenance is calling that machine learning function. So every time I have a new window for a certain device that is being triggered, I call that API, that service in Azure Machine Learning. Apologies. And based on that, if it needs maintenance, it will automatically be outputted into the output, which was in this case stable storage. All right? One thing I also want to share is that you can package your Stream Analytics model or query, and you can run it on the edge. So again, if you say, I want to have this functionality, but I want to run it closer to my machines in my factory and so on, you can just define your query and make it available for edge, and it becomes, you install the image of Azure Stream Analytics, and you link it with your query. And it will be using your local edge, which is actually a mini version of IoT Hub, to do your queries as well. Apologies. Yes? So the question I understand is, Apologies for the voice. Is there any indexing options possible to tune, I guess? As far as I know, no. And so no indexing hints and so on, but if someone can say yes, I haven't seen it in my experience.
Other than the main indexing that's done on time-based, you can't add a supporting index for some other elements within what's being connected?
A very similar thing that you get we have customers that say this is not rich enough, because the advantage of Stream Analytics is that you get SQL. The learning curve is not that high. The alternative that we see is in Databricks or in Spark is with structured streaming, where you have a very similar approach, but with a different syntax. And it might be possible because you define some tables and so on to have indexing in that case. Okay. Now to wrap up, before we have the party, this is the overall architecture that I talked about. So as a repeat, we talked about IoT Hub as the ingestion point for these 3 other services, so time series, Kusto, and Stream Analytics. And again, it's really integrated. I did not have to write code to do that. It's all automatically. So time series is reading, Kusto is reading, and Stream Analytics, they are foreseeing in the compute. So it's quite serverless on that level. Then I had machine learning for the whole ML ops approach and hosting that model that I call from Stream Analytics. So again, it's integrated there. What I really think is important, that I did not dive in the details, is on the top right, is detecting an event, like this device needs maintenance. You should fully isolate that from handling that event. And that's what I see Event Grid in a perfect case. So I detect in my Stream Analytics query, this engine needs maintenance. The only thing I will do is raise that as an event. What happens with the event is not up to my query, in my opinion. That's, in my case now, logic apps that will subscribe on that. I think that's an important takeaway. So, wrapping up, I would say there's no harm, or there's always a win, a quick win, in just ingesting your data in time series insights if you talk about IoT or time series data, because you get rich visualization and exploration capabilities, in the hour. Without much effort, you can start doing that. So that's your data exploration and so on. If you really need more power and more advanced queries, Kusto will be your friend and then enemy at the same time. And if you do machine learning, please think about ML ops. So make sure that you look at it as you would look at your software. We have been doing this journey of DevOps, with software companies for 20 years. This is something that for machine learning, I think we should also do. And as I said, there's a lot of out-of-the-box integrations with it. So think about Power BI, think about your data lake and so on, that all get integrated. Before we go to the party, any questions, you can raise your hand or contact me afterwards. One question there.
What would you say is the cost driver in Azure on this?
The cost driver in like what's most costly?
Yeah.
So I think Stream Analytics can become quite costly if your queries are like the larger time windows and you have a lot of data, then you typically need to scale. So that's definitely one that can become costly. And Kusto, if you use that one. I think those ones. The services that I talked about, they typically will cost more if you have more data and if you keep the data longer, let's say warm. That's when if you want to reduce cost, that's what you have to do. Either have data into the cold storage or have less data. And sometimes it makes sense. It doesn't make sense to have every second the temperature of this room. What we see in the edge, for example, is that we will filter and have intelligence there to not send every message there, and maybe only send it if there's more than 0.5% deviation from the last measurement that we've sent. Things like that can have a big impact on services like this. Okay? Yep. Any other questions?
When would you use this over Databricks or the other way
I think the services that I showed, maybe except for Custo, have a very good fit with people that are not coming from the data world and the open source Databricks, Spark area, but are more coming from the SQL and the .NET world. I think for them, the learning curve is definitely much lower and a good starting point. If you want to have the real integration and the real power of everything, Databricks is definitely a good place to go, especially if you have, let's say, the link with the whole open source community from the data Spark side and so on. So I'm not saying that it's necessarily a matter of functionality. It might be more a matter of knowledge and learning. Make sense? Other questions?
You mentioned earlier about integration with the Azure Digital Twins, if I remember well. Yeah.
Yes.
Have you worked on some projects when integrating this digital twins in this stack here?
I'm waiting for a long time to see the integration coming. So it's on there. If you would look at one of the public slides they have, so it's not NDA, was, for example, time series insights would come on the edge. Integration of the hierarchy that I've showed in things, that is planned to have it automatically integrated with digital twins, because digital twins has the graph and so on. So you would see that all of that is...
Right now, the hierarchy that you mentioned is a complete...
It's separate. So as far as I know, unless if there's now a private preview that started that I missed, it's not available out of the box. But it's definitely their public intention. But it seems to be an intention for quite a while.
What about the integration with the Cosmo and the Gremlin API? Any experience or opinions about that? Like challenges, possible challenges, or...
I think that would be more on the right side, right? Towards, I think with functions could be a nice proxy to have. I don't think there's out-of-the-box integration for those things, unless if I miss it.
No.
Okay? Anything else?
Probably an answer to the gentleman's question. I'm just having a quick look. It looks like it's column store. Some form of column store.
So it's column store. Thanks for that. Then I thank you for coming, and I really hope you enjoy the rest of the conference, even if it might be online tomorrow. But the beers will be real for now. So thanks for coming.